Hello dear student, this is me again, Mr. Ahmed Karim at the private Zhyar in the basic school. So we have reached a section 7 in chapter 1 and it is compound inequalities. In the previous lesson, if you remember, we have explained solving inequalities and multi-step inequalities. I'm going to give you a quick note about the previous subjects. The first one was solving inequality, when we had single-step inequalities that we could solve them in one step. For example, y plus 3 greater than 4. This is a single-step inequality. We could solve it so easily. And we had addition inequality, subtraction inequality, and also we had division inequality. After that, we had multi-step inequalities. For example, 2x plus 3 less than or equal to 5. Okay, right now we have an inequality we called multi-step inequality because we need more than one step to solve this kind of inequality. So today we have a new subject that is compound inequalities. From the name compound, from this word, you can notice that we have two things that we, let's say, combine them together by and also we have or. So we can say when two simple inequalities are combined into one statement by words and or, the result is going to be, we call it compound inequality. So before we solve any example about compound inequality, let's give you some examples. For example, you have x less than 4, okay, greater than negative 2. We can see that we have two inequalities. We combine them by and also we can say x less than 2 or x greater than 5. So these two examples are compound inequality. You can see that we have 1 and 2 inequality. We combine them with and with or, and here we have and x less than 4 and x greater than negative 2. This is the way we read it. X less than 4 and x greater than negative 2. And here x less than 2 or x greater than 5. This is about the compound inequality. Then we have an important note, that is when we have a graph, how do you know that? Is it an and graph or graph? So the note is, the rule is, and graph, if the inequality is and, okay, the graph will be one part. What does it mean? For example, we have this graph, 1, 2, 3, 4, negative 1, negative 2. And graph is one part. For example, let's say we have this graph. Okay, we can see that the graph is one part. So this is and graph. It means the inequality consists of and. But or graph is two parts. For example, this is the number line. We have 0, 1, 2, 3, 4, 5. And we have negative 1, negative 2, negative 3. So it's quite clear. You can see that the graph is two parts. One go to the, let's say, goes to the left side, and the other one goes to the right side. Again, I'm going to repeat it. The and graph is only one part, and the or graph is two parts. One of them goes to the left side, and the other one goes to the right side. So without having any inequality here, we can notice that these two inequalities, you can differentiate between them. This one's and the other one is or. So right now we have some examples about compound inequality. The first example is 4x, x plus 2 less than or equal to 8 and greater than or equal to 4. How can we solve these kind of examples? It's quite easy. Just stay with me and focus. First step, put your hand on the right side. If you skip this side here, then we have x plus 2 greater than or equal to 4. Okay? Then the inequality is and. Skip this part or cover this part. You can see that we have x plus 2 less than or equal to 8. So write x plus 2 less than or equal to 8. Then we have two simple inequalities. We could solve them so easily. Then for the first one, move positive 2 to the other side. X stays here. And also you have 4. Positive 2, it's going to be negative 2. So x is greater than 2. And for the right part, we have x plus 2 less than or equal to 8. Move positive 2 to the other side. We have x less than or equal to 8. Okay, positive 2 is going to be negative 2. So the result is going to be x less than or equal to 6. So we have x, okay, here x is less than or equal to 6, and the other part we have x greater than or equal, this is an extra sign here, x greater than or equal to 2. So this is the solution. Then for drawing the graph, let's graph the first part. X less than or equal to 6. So this is first step. Try to mark the number. Okay. Then we are going to fill it because we have equal. Then it goes to the left side. Why it goes to the left side? Because x is less than 6. Then the other part, x is greater than 2. Mark 2 and fill the blank, fill the circle because there is equal, and the solution goes to the right side. If you notice the graph, we can see that this is our graph. They intersect in this area. This is the first graph. Now this one, the second graph, they intersect in that area, in that, let's say, part. Not area, this is not area. Okay, this is the solution. And you can see that the graph is one part because the inequality is and. Then we have another example is 5. We have 2x plus 3 less than 9. And in the other side, you have greater than or equal negative 5. As I told you, we are going to separate them. First, right, the left side you have, if you cover this side, we have 2x plus 3 greater than or equal to negative 5. And we have 2x plus 3 less than 9. Again, we have two inequalities. This is the first inequality, and the second inequality, we are going to solve them separately. So for the first one, move 3 to the other side. 2x stays here. We have negative 5. Because it is plus 3, it's going to be negative 3. So we have 2x, negative 5 minus 3 is going to be negative 8. Right now we have multiplication inequality. To get rid of the 2, we are going to divide it by 2. 2 divided by 2, only x remains. Negative 8 divided by 2, it's going to be negative 4. This is the left side. Then for the other side, again, do the same steps. Move 3 to the other side. So 2x less than 9 plus 3, it's going to be minus 3. So 2x less than 6. Again, because with the variable x we have 2, we are going to divide both sides by 2. Divided by 2. 2 divided by 2, only x remains, is going to be 1, and less than 6 divided by 2 is going to be 3. So this is our solution. X less than 3 and x greater than or equal to negative 4. How to write as one part? Write down x less than 3 greater than or equal negative 4. This is the solution, and also this is the graph of the solution. And for this time, we have OR inequality. We have OR inequality. So students, the only difference, you have to be careful, the only difference between, let's say, AND or equal inequality, it is the graph. So the way we solve it, it's the same way. Okay, there's no new way to solve OR, let's say, AND inequality. Maybe you see it's different. It's not different. We have only one way to solve all the examples. The only difference between them is the graph. So we have negative 4 plus a greater than 1, or negative 4 plus a less than negative 3. So we solve them separately. First, you have negative 4 plus a greater than 1, or negative 4 plus a less than negative 3. So for the first one, for the first part, the variable is a. This time we don't have x, we have a. Then with the variable a, there is negative 4, move it to the other side. A is greater than 1. Negative 4 is going to be positive 4. So a is greater than 5. Or, again, move negative 4 to the other side. A less than negative 3 plus 4. Because you have negative 4, it's going to be positive 4. So the result is a is less than negative 3 plus 4 is going to be 1. So the solution is a greater than 5, or a is less than 5. So let's graph this inequality. This is the number line. We have 0, negative 1, negative 2, negative 3. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. Let's add up 7. Okay. The first one is a greater than 5. The number is 5. This is 5. Okay. The number is 5. Then there is no equal, so we leave the circle empty. A is greater than 5. It means it goes to the right side. The other part, the number is 1, circle 1. There is no equal, so it's empty. A less than 1, so go to the left side. You can see that because we have OR inequality, so the graph is two parts. One goes to the left side and the other one goes to the right side. So this is the graph of OR. Then we have another example. 2x less than or equal to 6 or 3x greater than 12. It's quite simple to solve this example. We can see that we have two multiplication inequality. 2x less than or equal to 6, 3x greater than 12. For the first one, because with x we have 2, so we divide both sides by 2. 2 divided by 2, x remains, less than or equal 6 divided by 2 is 3. Or, but for the second one, we divided by 3, because with the variable x we have 3. So 3 divided by 3, x remains, greater than 12 divided by 3 is equal 4. And this is the graph. X is less than or equal to 3. This is 3. We have equal with it. That's why we fill it. Then it goes to the left side. And the other part we have x greater than 4. This is 4. There is no equal with it. That's why we leave it empty. Then it goes to the right side. The graph is 2 parts because the inequality is or. So finally we have some Nishtimani questions. We are going to solve it and we choose the correct answer. It says, what is the solution of the inequality? We have that inequality. It is 3x minus 4 less than 20 and greater than 11. As always, we are going to solve them separately. 3x minus 4 greater than 11 and 3x minus 4 less than 20. Okay, so let's solve it. The first part, because we have negative 4, move it to the other side. 3x remains here, greater than 11. Minus 4 is going to be plus 4. So the result is 3x greater than 15. With the variable x, we have 3, so divided by 3, x remains. 15 divided by 3 is 5. This is the left side. For the right side, again, we have negative 4, move it to the other side, so 3x less than 20 plus 4. It is 20 plus 4. Then 3x less than 20 plus 4 is 24. Again, we divided by 3, 3 and 3 cancels. X less than 24 divided by 3 is 8. So the solution is x less than 8 and greater than 5. This is the first question. And the solution is x less than 8 and greater than 5. So this is it is A. We choose A is the correct answer. A is the correct answer. Then for the question 2, we have or inequality. It says negative 4x plus x greater than 1, or negative 4 plus x is less than negative 3. In the examples, we have solved that example, but there we had a instead of x, so it's a repeated example. Let's solve question number 5. Okay, because the rest of the question are repeated. We have which is the solution, or which one is the solution of the compound inequality, 2x less than 6 or 3x greater than 12. Okay, so the first part, we have 2x less than or equal to 6. We divide by 2 divided by 2, so x is less than or equal to 6 divided by 2 is 3. Or 3x greater than 12 divided by 3 divided by 3. So x is greater than 12. So we are going to choose the correct answer. X less than or equal to 3, or x is greater than, sorry, it's 12, 4. Because 12 divided by 3 is going to be 4. So the correct answer is B. Then one of the important question is question 6. Right now, we don't have any inequalities to solve it. We have a graph that we have to find the inequality of that graph. So how to solve it? Maybe you think that's a difficult question, but it's not. It's really easy. If you look at the graph, it is OR inequality, okay? It is OR inequality. How do you know that? Because it is 2 parts. So we are going to write OR, we have x, and also we have x. Then what are the numbers? What are the numbers? The first number is, we have 0, 1, 2, 3. So it is 3. The second number, 3, 4, 5. So it is 5. So right now we wrote OR inequality, then we have x, the number, and also x, the number. The only thing that's left is we should write the inequality sign. For the first one, we can see that it goes to the left side. That's why we should write less than. Do you have equal? No, because it's not filled. That's why you do not write equal. The second one, the 5, because it goes to the right side, it means x is greater than 5, and also we don't have equal here. So the solution is x less than 3 or x greater than 5. It means the answer is C. So dear students, thank you so much for watching. This is the end of chapter 1, section 7, compound inequality. I wish you get benefit from me. Thank you so much.